So this is a simple, quick exercise before we get to the bigger ones. All I'm asking you to do is draw what this tree would look like scheme-wise. And that's very similar to what we just saw in the previous video and previous page of notes here, where it's lists instead of the nodes that we have here. So I want you to draw like a scheme list overall setup tree would look like. And then number two is, notice I did not ask you to code above yet and why, and there's a very simple answer to this. Don't make it too hard. But take a look at this, and then we'll go over an answer here in a moment. So here is our answer. And there's actually one thing I'd add to the answer. And the answer is right here. Everything from the red up I'm great with. It's actually the green children nodes that I'm a little more concerned about. So you notice that in 12 had three kids of a 16, a null, and a 13. And that's just fine the way it's set up at first. But notice I can create a list of just one item in it. Now, you'll notice that we have a null for one of the items in the list. So the null could have been left alone and had been placed in the original list that called it as null and stay there. So there may not have exactly technically been a kid, but I'm okay with it. Let's just put it that way. If you can understand the overall big picture like you see here, then we're in great shape. I'm not going to be super picky about nulls and where they end up and stuff like that. But remember, you can have a list of just one item in it. It's not really called a list, but it is a list, you know. It could be some more items can be added to this later on. Now, by the way, notice I'm not really talking about other functions that we've talked about in data structure, stuff like that, like changing a node in a tree, deleting a node in a tree. I'm not going down that too deep. You might have other instructors that teach this and go really deep in that. I'm not. Frankly, because we've gone over lists, you know how to remove items from a list. Yes, this gets extremely ugly, but it's still the pointers and everything else you have to worry about. But doing all that in Scheme, yeah. So notice I'm trying to keep things quick and simple when it comes to a tree. We can add more, but I'm not into that right now. I just want to get into the ADT for you so you can have some understanding that in reality, your own trees behind the scenes, no matter the programming language, is really this. That's really what they're using is going to be a list because, again, you have a generics in Java or template in a C++ or collections and, oh man, it gets generics. You have all these items that we're going to try to make it as much as possible the same structure over and over again. That's really what Scheme is doing, is using the lists. Lists are heterogeneous, and Scheme is very similar to what you're already using in C++ and Java. So I want you to realize that, which I'm hoping you are now, and that's why I'm also not going too deep when it comes to Scheme ADTs, because things can get ugly, put it that way. So here's your answer for this.